CIT 226, Data Integrity and Security. And the book we are covering is Database Security, and chapter number 7 talks about SQL injection. We are just trying to understand the identification of SQL injection. Describe an SQL injection and identify how injections are executed. Then we'll identify how web applications work and its role in SQL injections. Then we'll define how to locate SQL vulnerabilities using error messages, apply inferential testing, and then we'll review the source code manually to locate the injection vulnerabilities. Further methods for automatic traversing of source code to locate the injection vulnerability. Now let's try to understand what is an SQL injection. SQL injection method is used by intruders to break into the database and websites. So illegally, by using some commands, they gain access to the SQL database where all username and password of the users are exposed. Based on that, they log into the database either by using the management studio within the network, or they use the website through which they gain access to the information on the application itself. Now, since all web applications these days are linked to the databases, if they'll get the administrator username and password, they'll be able to get almost all the information which is related to the content which is available on the website. Further, there are tools through which you can browse the contents and run or execute the queries on the remote server in order to extract the information. Now, for web application testing, etc., I told you Burp Suite is one of the best applications available. It's available for free as well as in a premium version of it, but it helps you in testing your web applications and any known vulnerabilities on the web applications. Since it's about the SQL injection, mostly we'll be focusing on the problems with the SQL server, but we cannot deny the fact that most of the applications and websites are compromised by following poor programming practices as well. If the programmer himself is not aware of the known vulnerabilities of a application or the database designing itself, there are high chances that he'll end up facing the problem which is mostly involved related to SQL injection. Intruders use bits of SQL code and SQL queries to gain database access, create vulnerabilities, and can allow intruder to obtain full administrative privileges. Now, as we discussed in penetration testing course as well, they create the user accounts which would be a system administrator account using different usernames. It won't be the admin or administrator, but it would have the privileges of a system administrator, so that remotely as well as on the application or through the application, they'll be able to perform lots of operations which they are not allowed to do. 3 common strategies for SQL injection are single channel, multi-channel, and observational. Now, single channel attack is an intruder uses a channel to execute SQL injection and obtain the returned results. So he'll pass a query and he'll get the results for that by entering an injection into a web application. They'll keep on trying because the interface for a username and password usually comes through the web application that you are using. If we'll take example of Drupal, WordPress, or Joomla, Moodle, etc., we have a user account and then we have the administrator login account, where the administrator would log in with his login credentials and he'll have access to modification of the website and all the other related data which is available on the website. Now, if you're logged in through the administrator account, you can download the files uploaded by the users, you can download the grades if it's Moodle, you can download the content, PDF documents, Excel sheets, and all related information which could be useful for any penetrator. That's why they are talking about the web application. Multi-channel attack is an intruder uses one avenue to initiate the injection, uses a different channel to obtain the results. means that they are using different channels to perform different operations. Maybe one operation or one task would be performed through the local database which is available on premises, and the other one could be through the web application which is hosted on the web servers. Now, not all intruders will have access to the local database. Maybe your local firewall is blocking access to that specific database since it's located within the organization. They'll have to find the ports through which the external websites are communicating to that specific database. Second try would be through the web application which is hosted on the website, and then they try to find the vulnerabilities of those websites. Now, inferential injections or intruders does not intend to receive the data, observes and learns from returned behavior. For example, if you passed on credentials, you entered a username and password and you press submit it, so what's happening in the background? And as I told you that if you are monitoring the background code of Chrome browser, it tells you exactly that what's happening. You sent a command, get results or post or update or anything, and then which table it's going in order to fetch the information. You can get those details, and then they use the Burp Suite and softwares like that in order to translate the information which was being transferred between the computer and the database, and once the information comes back. By that, they find out the exact name of the fields where it's trying to validate the users against a username and password, and then those username and passwords are usually used to log into the databases. Most SQL injections performed through a web application interface with backend database. Of course, if it's an application which is a web-based application and it's a dynamic application, there will be a backend database. Now, we'll have to understand that there is a difference between a dynamic website and a static website. A static website is a website where we don't have a database connectivity. So, any information which is there on the website is simple in HTML or JavaScript or CSS. But there is no database attached to it. The problem in that is that if you need to update information, you need to update it on all pages on the website. Whereas in a dynamic database, you have a database connected at the back end. Whatever changes you are making in the database in the back end would be reflected to the entire website. So it makes it easy for the webmasters to manage the website. For example, if you have a link updated on a website, you don't need to worry about that you need to update it in all 2000 or 2500 pages on the website. The moment it's updated in the database, it would be updated automatically throughout the website. Same goes for the categories, pages, and information related to certain things. If a company was offering certain services and they are not offering those services anymore, all they need to do is just disable that category, so all information related to the pages which were falling in that category would disappear from the website. So you don't need to hide that information. We use web applications using a database connectivity for sales, online procurement, and then buying and selling and stuff. So you can maintain the records only if you have a database which is giving you a live feed of how much items do you have on stock. Further, if the users would like to get the updated information about if the item has been dispatched or not, what's the status of the item, how much time would it take to arrive at the destination, all that information is coming from the backend database. Whether they are applications, buying and selling website, banking, or anything, we have databases running in the background. Now, it really depends what kind of database is there and what are the protection mechanisms for that, what are the audits of it, who's checking it. So we make sure that the information which remains on the databases itself remains 100% secure, and people are not able to gain access to the databases in order to compromise the data which is saved on the database. Web applications are common today. Examples: email access. Even if you're using a Exchange server, in order to get your emails, there is a database of the username and passwords, which is Active Directory. Now, if they are using a web-based service, they'll be using Active Directory Federation services online through which you are authenticated, but a database is there in the back end. For auctions, shopping, banking, blogging, and online gaming, etc., every website in these categories usually have a back-end database. Primary target for the intruders is the database because it has all the relevant information. Now, if an intruder is trying to penetrate on a database itself, and if the database is maintaining the records of the credit cards, purchasing details, user email accounts, mobile numbers, and all those information, it is very important for the intruders, especially if it's a banking website. They end up gaining a lot of benefit by penetrating in the websites for the financial institutions. Now, general steps for retrieving and manipulating the data in web application is user accesses the specific website, site displays form and field of input. Form resides on the web server and uses HTML and a scripting language in order to reach to the database to validate the credentials of the administrator or a local user account. Scripting language reacts to the user submission that you have submitted the results, on which table it would go to verify the credentials, and then SQL statements are passed in the company's application or middleware server to know that where it's getting the details from. Middleware server acts as the interface of the database, and the database receives the query and returns the results for the application server. So once the username and password is verified on the application itself, that okay, I know you are a user, you are authorized to log into the server, you'll get a welcome screen and the rest of the information. Otherwise, you'll get a notification that incorrect username and password. So sometimes they try a different combinations in order to gain access to that. An application server returns the results to the scripting language on the web server, and scripting language along with HTML displays the results on the screen. Now, that's why they always say that you must always change the default username and passwords whatever are there on the databases itself. Make sure that the username as admin, administrator, or root is not used, which is quite common because any new hacker in the field, definitely they are going to try these basic things. Now, sometimes the applications which are meant for testing and they are being tested online on the web servers, people don't change the username and password. It's fine during the testing purpose, but if your application is exposed to the outside internet, expect that anyone can search for those details and would try to log in. By the end of the chapter, we'll be looking at certain ways through which we can enter the information on Google, and it gives us lots of information about the applications and things which are hosted on the web servers. So when Google can find that basic information from the websites, hackers can do lots more things on these web applications and web servers as compared to the basic crawlers that we use these days. Now, SQL injections deployed at the beginning process. Two ways of SQL injections cause destruction. Lethal SQL code placed into user input field and executed at the database. Now a written code sent to the stored in the database. Primary method for detecting injections is to ensure the applications validates the user input without sending it to the database. So the input field, we have an input mask that you provide when you are designing an application. That, for example, this field will take only alphabets. This field will take only numbers. So when you are defining when you are designing the web application, you have all these checks and balances over there, so that you'll control it, that if your web interface for the form is not accepting any special characters or symbols or things which looks like a syntax of a structured query language, SQL, which could be executed while it is entered in the username or password field. Now, primary method is detecting, ensuring the application validates the user input before sending it to the database. So if it would detect it, it would automatically say that it is not allowed, you cannot do it. Now there are two ways to catch the exception. One way is to do it on the application itself. Long time ago, people used to use the Java scripts in order to check that, because that was easy. That as soon as it's entered, it would pop a message that sorry, this entry is not allowed. But the workaround for that was that if you disable the Java pop-ups or the Java execution on the website, they were able to execute the same code without getting any warnings. Now SQL Server, MySQL and Oracle all at risk if applications are not properly secured. So you cannot say that the database was not defined or was not developed in a very secure or by not following the proper principles for securing a database. And application plays an important role as well, because if application is not written well, there are high chances that your database and your information can be leaked out. Just like I told you that the web config file in ASP.NET, when you are defining or when you are designing an application, your web config file usually have all the login credentials for your database and the tables where it's getting the information from. So there should be a way in order to encrypt all that information so that even if the web service is compromised, your database remains intact, because the config file usually, if not designed properly, would have all the login details of the remote database with the IP address and login credentials. So anyone can easily gain access. If the server is compromised, your database would be compromised as well. Developers build applications that handle most of the SQL code in the real time. Static SQL statements built by the user in which full text is known at compilation. Now web applications displays input fields to the users, and users fill the criteria, and application uses these to search the database. 3 fields, for example, name, title, and department, etc., is usually very common, which is used in order to get the information. The static SQL statement could need to take into account all possible combinations of the user input which they can have in the field before they can verify the credentials. Dynamic SQL statements are best for web database access, vulnerable if input is not validated. For example, they are saying if a user inputs syntax as or 1 equals 1, that would be always true, because 1 is always equal to 1. So often returns first entry in a given table, which would show the first data entry that you have in the SQL table. If attacker places above the syntax in the username and password field, where application creates SQL statement that checks username and password table and uses the first entry as the attacker credentials. Always that at least one user in the database, so the attacker is authenticated. Once he is authenticated using that account, then he can play around and get the other relevant information through that. Now, if administrator account is listed first, attacker has obtained the administrator privileges. Now, why they are saying that the first result is returned? Because whenever we define or whenever we are creating an application, the first account usually that we create is usually of the administrator, because he'll be testing the application, but he'll be accessing a database from a remote location. So the first account is usually created for the administrator, and if it is at number 1, of course they'll get access to that and your entire application is compromised. Primary step towards securing the data is securing the actions fruitless without knowledge of system weakness. Play the role of the intruder to find the vulnerability. Several different types of attacks, different areas of network can be attacked, and different methods of deploying the injections can proceed. So it all depends on how the application is written, how it is saved, how it's executing the code on the remote server, and what sort of information is displayed once the user is successfully authenticated. Now, inferential testing for locating the SQL injection is look for the clues in behaviors returned from the database in response to the controlled attack. You passed on credentials for username and password. You're not authenticated, so what kind of information do you get on the screen? Further, where is it going actually in order to get the details, whether it's going into the main user table having all the details of the users, or it's going to the user table only in order to authenticate the details. Administrator must input parameters from the client side to the database environment, observe the database behavior, document abnormal responses that you get whenever you pass on credentials. Like if you'll try to enter any code instead of the username, what would be the response? How the application would catch it? What kind of response it would show you on screen? Whether it would show you incorrect username, or it would show you incorrect password, or it would show you incorrect username and password. Now, what happens is that if you are writing you are displaying an information very specific that the username is incorrect, the attacker would easily guess that this username is not found in the database. So he'll keep on trying, because some applications show that okay, username is correct but password is wrong. So it would say that okay, yes, the username that you're trying exists on the database, but the password is wrong. So his half task is accomplished because he has verified that the username exists on the database. Otherwise, mostly they just show a blank statement on the website that incorrect username or password. So you cannot guess that whether it's verifying the username or the password. Administrator must be familiar with the application and web browser behavior during the normal data and retrieval, that if everything is okay, username and password is passed on, clearly what would happen next. Using HTTP, all network communication based on the basic principles. Client send request to obtain the source. Request is received and processed. Client privilege is checked to determine allowable permissions. Once approved, request resource packaged and sent to the server to the client. Each step handled using standard protocols. So when we are accessing any application through a website, we'll have to make sure that the communication which is taking place between that website and the web server or the remote server is a secure communication. Now there are two kinds of communications which take place. If you are defining or when you are making a website, make sure that your web server is also HTTPS, which is a secure communication. If it's a simple HTTP website, it's not secure. So if you're passing on any credentials, they can be sniffed, or they can be checked in the background if an attacker is constantly looking for what kind of information is flowing on that specific page, using capturing packets and things like that. But if it's HTTPS, secure communication, it is a bit secure, but still you'll have to work on the input fields which you define when defining or when designing a web application. TCP defines the rules to ensure the reliable virtual connection, and HTTP defines formatting method for the HTTP request and responses. When request made from a web application to the database server, HTTP initiate TCP connection as a transfer agent in order to access the IP address of your remote SQL server or database, whatever you are using, in order to get the information by 8 predefined actions, including HTTP head, get, post, put, delete, trace, options, or connect. You might have seen it when you were designing any application, a web application, using any sort of database. Now, two actions relevant to SQL injection is the get and post. So this is a common thing which is used when you are defining or when you are making a web application. Get requests encoded by the browser into the user, and server execute parameters append the URL itself. Post request the user to input the included in the body of the request, not in the URL. Application server recognizes the post action and searches the body and request for the statements to send to the database to execute. For example, the user is logging in, it would take the username, it would search for the username in the database, and it would verify the credentials if they are matching based on the username. User requests can be intercepted during the transit from a web application to the web server. It can only remain secure if it's a secure communication between the web application and the database. User data can be switched by SQL injections. Unauthorized user can place SQL statements into the form fields and execute it. Third-party applications that intercept and manipulate the HTTP data, for example, Wireshark, they can capture the packets and the communication which is taking place between the web application and the database. Now, browser add-ons and plugins are also there through which they intercept the data which is flowing. Now, proxy servers enable interception and modification of HTTP requests using one of the preceding tools and intercept and observe the network get, post, parameters, etc. Now, we'll continue determining the vulnerability through errors in our next lecture.